Welcome back. This is the second of 3 videos on U substitution. Today we're going to talk about definite integrals. And so on the board you'll see that I have the definite integral from -1 to 3 of the quantity x over x squared plus 1 dx. By this time you've had enough practice that I hope you're getting really good at picking the u. And so u here will be x squared plus 1. I'm going to take a shortcut here. And that is, I'm going to not only take the derivative of both sides, but at the same time I'm going to move the denominator of du dx over to the right. And then the last thing I do, of course, because I don't want 2x dx, I want x dx, I move that 2 over. So here we go, we get the integral of, let's see, 1 over x squared plus 1 would be u to the -1 du. Don't forget the 1/2 out in front. Alright, so now we need to talk about the bounds. And so the bounds, this is really the only thing that's truly different in today's lesson. We need to know that the -1 and the 3 are bounds for when we're in x. When we're in u, we have to change the bounds, and what tells us how to change the bounds is the equation u equals x squared plus 1. So when u equals -1, when we add -1 squared plus 1, we get 2. So our lower bound will be 2. When x is 3, 3 squared plus 1 is 10. So now our bounds have changed from -1 to 3 to 2 to 10. So what we do now is what we've done before, and that is to integrate. And the integral of u to the -1 is ln of u. Don't forget the 1/2. We usually put an absolute value around the u, but in this case we know that we're evaluating at 2 and 10, so we don't need to. So here we go, we're going to evaluate. We get 1/2 ln of 10 minus, and I'm going to use parentheses here, ln of 2, and using our log properties, the final answer would be 1/2 ln of 5. Now you might be wondering, don't I need to go back to this original u? And the answer is no. With a definite integral, as long as you change the bounds, you are evaluating the integral in u, not the integral in x. Alright? So hopefully that makes a lot of sense. Let's go on to one. It's a little bit more challenging. This time it's a power of e. So let's go from the integral from 1 to 2 of x squared e to the x cubed dx. So I'm going to pick u to be x cubed, and so I get 1/3 du equals x squared dx. See, I'm taking even more shortcuts. I hope you're following along. So if that's the case, then I can rewrite this integral. E to the x cubed is e to the u, and x squared dx is 1/3 du. My old bounds 1 and 2 now become 1 and 8. Do you see why? So u equals x cubed means to cube each of those bounds. So here we go. The integral of e to the u is e to the u. Don't forget the 1/3. And we're integrating at 1 and 8. So I get 1/3 e to the 8 minus e to the 1. So final answer, e to the 8 minus e to the 1 over 3. Okay, are you having fun yet? I hope so. Let's go ahead and do one with the natural log. I think we've done this one in class before. This time I'm going from 1 to e of ln of x over x dx. And I always say that when you've got a complicated integral like this, if you can rewrite it so that it makes more sense when you pick the u substitution, you should do that. So all I did was I separated the fraction and I said ln of x over x is ln of x times 1 over x. So I know that the derivative of the natural log is 1 over x. So I'm going to pick the u to be the natural log, and so the derivative of u is going to be 1 over x dx. Okay? And so this becomes a super simple u du is my integral. I don't even have a fraction out in front. Now I just have to make sure I change those bounds. And so the ln of 1 is equal to 0, and the natural log of e is equal to 1. And so my bounds have changed from 1 to e to 0 to 1, and so the antiderivative of u is u squared over 2. And so, boy, we have a lot of problems that are 1/2 for an answer. I think that's just a coincidence. Okay, last one. Here we go. Last one. Sometimes we have trig functions, and so it's really important that we always have our exact values right on the tip of our tongue, as well as the relationship between the trig functions as far as derivatives go. All right? And so we've got the tangent and the secant, and so that rule I told you in the first video to look for the function that's the innermost does not apply here. What applies is that you remember, okay, so this is your brain, and this is what you remember, is a long time ago we took the derivative of the tangent and we got the secant squared, right? So you remember that. So here's what I'm going to do is I'm going to pick u to be the tangent, because when I take the derivative I get secant squared x, right? And here we go again. This can be simply written as u du, right? Because here's u, tan, and here's du. Now instead of from 0 to pi over 4, I need to find the tangent of each of those, and this is where your exact values come in. The tangent of 0 is 0, the tangent of pi over 4 is 1, and so now you get the integral, and if it looks familiar, it sure looks like the one we just did. Integral is u squared over 2, and at 0 and 1 gives me a final answer of 1/2. Okay, great. Those are definite integrals, how we change the bounds. I hope this makes a lot of sense. We'll see you in class. Get ready for video 3.